Okay, hello everybody. What's going on? This is Muhammad. Welcome to another video. In this video, I'm going to show you how to solve for the radius r. So we have here a square of side length 1 centimeters. Okay, and we have two identical circles of radius r. Okay, so the question is to solve for the radius r. So how can we solve for this problem? Okay, so first of all, what I'm gonna do, I will try to find the side length in terms of r. So I will connect, this line here. So that's gonna form, we all know that the radius is perpendicular on the tangent. So this angle here is 90 degrees. Also, this angle here is also 90 degrees. Okay, so this is also r. And let me use the red color. No, okay, let's make it. Okay, so this is also r. Okay, and let's assume that the angle, now the angle here is 45 degrees, so half of that is going to be pi 8. Okay, so this angle here is pi by 8, and this one here is also, this angle also is pi by 8. Okay, so from that we can calculate the horizontal projection on the horizontal axis. Okay, so we can, let's assume that this distance here is equal to a, okay, and this distance here, the next one is b, and this distance here is c, and of course this distance is r. Okay, let me also draw a line here which is perpendicular on the vertical side length of the square. This is also r, which makes this r as well. Okay, so the remaining distance, since the side length of the square is 1 centimeter, so the remaining length is going to be 1 minus r. Okay, which is basically, if we also draw a line here which is perpendicular on the tangent, this length here is going to be also 1 minus r. This is a, and this is also going to be a, so the remaining distance is going to be the square root of 2, which is basically because the diagonal of the square is 1 squared plus 1 squared under the square root, that's the square root of 2. So the remaining distance is the square root of 2 minus a. Okay, now we need to calculate for a, b, c, so that we can form like two equations in terms of, now the problem here, if we connect a line here, okay, we need to calculate for theta because we don't know what this angle is. So let's assume that the angle is, that the whole angle is alpha, so half of that is going to be alpha over 2. So I will assume that this is alpha over 2, and this other angle here is also alpha over 2. Okay, now the problem, or the key, to solve for this problem is to calculate for a, b, c in terms of r. So we can, in terms of r and alpha, so we can form an equation of r and alpha. Basically, we have two unknowns here, alpha and r. So if we can come up with two equations in terms of r and alpha, then we can solve for them, and then of course we can solve for r. So that's how we can solve for this problem. I will also connect a line here which is perpendicular on the tangent as well. Okay, so this angle here is 90 degrees. Okay, and the distance is also b. So so this distance here is also b. Okay, and the whole distance. Let me highlight that so the distance here, let me use smaller. So this distance here from here to here is c, and this distance here, let me highlight it in yellow, this distance here is b. So the remaining distance, or the difference between them, is c minus b. Okay, so I will highlight that in green. Okay, so this distance here, is going to be what? Is going to be, let me highlight it here. Okay, so this distance, the green distance here, is C minus B, which is the difference between C minus B. Now we know that the two external tangents coming from an external point to a circle, they will be of equal length, until they hit the circle. Okay, so this length here, let me highlight it in yellow, for example. This length, I'm sorry, let me use the highlight. Okay, so this length here, okay, is gonna be equal to this length here, this whole length. Okay, so it's gonna be 1 minus r plus c minus b. Okay, so first of all, let's go step by step. First of all, we need to calculate for a. So we know that tangent pi by 8 is equal to r divided by a, and that gives us the value of a as r divided by tangent of pi by 8. If we can calculate, we can express that as 1 plus the square root of 2 multiplied by r. So now we have expressed a in terms of r. Now let's do the same thing for b and c. b, now let's connect a line segment here. This angle here is going to be 90, each one of them. And let me use a red color here. Okay, so this angle here, okay, and I will mark it like this. This angle here is basically 90 degrees minus alpha over 2. Okay, which is the same as the other angle here. Okay, so this is okay, the same as this angle here. Okay, so these two angles are equal and they are 90 degrees minus alpha over 2. Okay, so let's now calculate for b. Let's take the tangent of 90 degrees minus alpha over 2. That's going to give us what? R divided by b. R divided by b. And from that we can calculate for b, of course. b is going to be equal to r divided by tangent of 90 minus alpha over 2. Tangent of 90 minus alpha over 2 is going to be the cotangent, and 1 over the cotangent is going to be the tangent. So that's going to give us r tangent of alpha over 2. So now we have also expressed b in terms of r and alpha. Let's do the same thing for c. So I'll take the tangent of alpha over 2. That's going to give me r divided by c. So from that we can calculate for c. So c is going to be equal to r divided by tangent. So it's going to be r cotangent of alpha divided by 2. So we have successfully expressed both a, b, c in terms of r and alpha. Now, to form our first equation of r and alpha, let's take this side length here, okay? Let me highlight it in green, okay? So this whole length here is equal to 1, okay? Which is basically a plus b plus c plus r. So that's what I'm gonna do to form my first equation. So a, which is basically 1 plus the square root of 2r plus let me make r as a common factor, so I'm not gonna write r now, okay? So 1 plus the square root of 2 plus b, where b is tangent of alpha over 2, plus c, which is cotangent, r cotangent, but I'm gonna take r as a common factor, so we're gonna be left out with cotangent of alpha over 2 plus r, which is equal, 1, all multiplied by r is going to give us the square side length, which is equal to 1. And that is basically our first equation. I'll just move it a little bit to the, I'll move everything actually a little bit to the left. So we have, okay, and I will call this equation number 1. Now, how to form my second equation, because we have basically two unknowns, so we need another equation in order to solve for alpha and r. So to do that, I will equate the yellow lengths here. The square root of 2 minus a, okay, and 1 minus r plus c minus b. So the square root of 2 minus a, where a is basically 1 plus the square root of 2 multiplied by r, is going to be equal to 1 minus r, okay, plus c minus b. Okay, now c minus b, I can take r as a common factor. Okay, and between two brackets, I can see cotangent alpha over 2 minus tangent alpha over 2, and that is basically my second equation. Now, if we solve equations 1 and 2 simultaneously, so solving equation 1 and equation 2 simultaneously, that is going to give us that alpha is going to be equal to, so to do this, basically we need to go, let me do it in front of you guys. So what I'm gonna do here, I'm gonna use the Wolfram alpha. So I will write my equations. Okay, so the first equation is gonna be E1. Let me use, okay, so 1 plus, I'm sorry, delete 1, yes, 1 plus the square root of 2 sqrt of 2. Oh, I can use the square root right away, so let me do that quickly. So square root of 2, okay, so 1 plus square root of 2 plus, and I have to use the shift plus tangent of x over 2. Let's assume that alpha is x over 2. Alpha over 2 is x. Let's use x instead of alpha. So tangent of x divided by 2 plus cotangent of also x divided by 2, x divided by 2. That's my first equation, plus 1. Okay, all multiplied, we need to multiply everything. Let me go back here. Okay, and I put a parenthesis here, and then multiply everything by r. That's gonna give us what? Our first equation, which is 1 here, okay? And I'll put a comma. That's my first equation. My second equation is gonna be equal to the square root of 2. So where's the square root? Square root of 2 minus, between parentheses, 1 plus square root of 2, and let me close the parentheses, all multiplied by r. That is going to be equal to 1 minus r, 1 minus r, plus r, and then I will open a parenthesis, cotangent plus tangent. Cotangent of x over 2, x divided by 2, plus tangent of x divided by 2, and I will close the parenthesis, and that's it. Let me hit enter, and let's see what is the solution for alpha and r here. So Wolfram alpha is calculating. No solutions exist. I guess there's a problem here. Let me double check my equations. 1 plus the square root of 2 plus tangent of x over 2 plus cotangent of x over 2 plus 1, all multiplied by r equals 1. The square root of 2 minus 1 plus the square root of 2 multiplied by r. 1 equals 1 minus r plus r. Cotangent minus, I'm sorry, this should be minus because it's the difference actually. So this should be negative. Okay, let me hit go again. I guess this should work now. Okay, let's wait for Wolfram alpha to calculate for r and alpha. Exactly. So this is the first answer is basically the right one. R is equal to 0.178203. That's the value of r, the radius of the circle, and the angle alpha is basically 0.571859 radians, which is basically equivalent to 32 angles approximately. Let me write that down here. Okay, so let's go back to our solution. Okay, and let me write the value of alpha and R. Alpha is going to be equal to 0.57. I'm sorry, 0.571 859 radians, which is basically equivalent to 32765107 degrees, and R, which is what we're trying to solve for, is 0.178203. That's the approximate answer, of course. I have double checked everything on GeoGebra, and the answer is absolutely correct. Okay, so let me highlight this in pink, and that is basically going to be the final answer to this problem. If you like this video, hit like, and don't forget to subscribe to the channel and click the bell so you don't miss anything in the future. Thank you for watching, and see you in another video. Thanks.